Hello, today we're going to use amortized loan as an opportunity to practice our if functions to make the model more flexible. Amortized loan is such as example auto loan payment, mortgage payment, where every period you pay off part of interest payment and also pay off some of the loans. Let me show you one example. So this is a loan pay off every year annual loan. We have a 6 year as a long term. The annual rate is 6%. And we can use a payment function, PMT function, and calculate what is the annual loan payment. So this is 8,652. Year by year, how do we calculate, update the interest payment, repayment of principal amount, or remaining balance? For interest payment, for example, for first year, 3,200 is based on at the beginning we own 40,000. Our loan rate is 8%, so 80% of 40,000, so that's 3,200 is interest payment. The total regular annual payment is made of two components. One is interest payment. The other remaining is going to pay off loan amount. So we reduced principal repayment is 5,452, which is from the difference between these two. As a result, as we paid off these amount of loans, our loan amount will be reduced. So remaining balance will be updated by reducing this amount. So the other years, we will use same type of calculations. So here's the formulas if you want to understand relationship. In practice, you may have a loan paid off earlier than original scheduled long term. This is a type of a balloon payment, right? You have enough money saved, you may pay off the remaining loan at one time. So we call it a balloon payment option. And they also could have extra payment option where you pay off additional more amount, and this will speed up your loan payment terms. So I'm going to go to the actual examples and let's do the practice. I'm going to do two examples. One is the basic version, and just help us to understand the loan, amortized loan, the calculation relationship. Then we will go to the actual loan, actual payment, and the balloon payment. So this is a loan. We have borrowed 40,000. The loan schedule is monthly, the long term 48 months. So as a result, month rate will be 8% divided by 12. So what we want to do is figure out the regular monthly payment and how we figure out month by month these payment, interest payment, principal repayment, and remaining balance. Okay. So what I'm going to do is first walk you through the calculation part. Then we want to make that more flexible by adding if functions. So this is the one without any information. To start with, I will do a starting point, which is month 0, where we have remaining balance of 40,000. So first of all, let's fill out the information if we know that in the output section. The monthly interest rate is 8% over 12 months. As this is an amortized loan, we can use payment function to find out what is the monthly loan payment. The rate, we will use monthly interest rate. We have 48 months. We borrowed 40,000. Okay, so this means every month we pay 976.52. We should pay off in the 48 months. So we will do these detailed calculation, demonstrate month by month updating. First, we will do the month indicator, right? So we are just adding 1. The monthly payment is fixed, right? 976 is the same amount. I'm going to use F4, lock this Next, let's do the interest payment. Interest payment is the remaining balance times the monthly rate. Again, I'm going to lock the interest rate reference. So 967 contains interest payment and the loan repayment. So the difference is the principal repayment, right? So this amount, $709 off, will reduce our loan remaining balance. That's it. So next I'm going to drag down all the way to your 48 months. Okay, that's way too much. Okay, so as you see, at the end of 48 months, remaining balance is 0, right? So if you look at the loan one with calculation C, this shows you that the calculation informations, right? So this works well if we only change like a loan amount information 40,000, 8%. But if we have different loan terms, 48, for example, to 36, that does not work well anymore. So next, that's why we want to work a version which we want to make the model flexible. So if the long term change from 48 to, for example, 50 months, we can still show appropriate adjustment. If long term reduced to 24, we can also show what is the correct answer. So how do we do that? Okay, so number one, we know all the calculation is supposed to be as the one here we already calculate. So all the calculation for the first 48 months should be something like this. And what we want to control is after 48 months, we don't want to display, right? Okay, so for the months, what we do is just like the one in the growing annuity example. We will compare the previous month's indicator, 0 in this case, with the 48, because 48 is our long term. And if it's still less than 48, means we are in the first 48 months, we will add increase the month's indicator by 1. If it's already after, we was going to don't display, right? Don't display. Okay, so that's for the months. Payment, interest payment, principal repayment, remaining balance. Again, we know all the correct calculation, the formulas, right? Formulas. The only thing we want to make sure these are correct formula only for the 48 months. After 48 months, we don't want to do those calculations. So one shortcut, one way to do this is, what we do is we check the month indicator. If the month indicator is like this, beyond 48, which is not displaying anything, we will also use double quotation, say we stopped displaying any information. Otherwise means the month has a valid month indicator. What we're going to do is include all the calculation we already agreed on for these first 48 months, right? So which is the month's reference, the month payment reference, the interest payment calculation, and principal repayment, remaining balance. Okay, that makes sense, right? So this is example 1. Okay, it's basic. What I'm going to do next is do the actual payment version. So suppose you are considering you may pay off a bit more, like $600 every month. Okay, so the actual payment, of course, comes all kind of different alternatives. So one way is you can do one time. One way you can do multiple time. So what I'm going to start with you with is a very basic version, which is we will do the actual payment all the way. Every month we do additional 600 more. Okay, so let's make it a bit simple. So later on, when you feel more comfortable, you can make the more different kind of extra payment. So okay, so as you see, we have 976. So add 600 more every month. You see, we will do 1576, right, instead of 967. And the interest payment, the principal repayment, the remaining balance, they are the same way of calculation. There's no difference, not impacted. But you do see that there's one impact is when we paying off more, of course we're going to speed up our long term, right? We don't need 48 months. We only need maybe, in this case, like 27, 28, we are able to pay off. That makes sense? Okay, so this is going to affect our actual long term is no longer 48, it's in this case 28. So what are we going to do? Okay, so first let me show you that this calculation part. Then we talk about how we update this actual payment in our calculation. So first, the payment is the regular plus extra 600. We do this, okay, all the way, right? All the way. But you notice that we don't need to all the way drag to 48, right? So the remaining balance already shows negative after doing 28, 29. But the interest, okay, these are the same calculation. I'm not going to repeat here. So first of all, let's figure out how long do we need to pay if we do extra payment all the way. So if you look at these informations, after 27 months, our remaining balance is 1391, right? Which is smaller than the 1576, which we are doing every month, right? The regular plus extra. So meaning after 27, we only need one more period to pay off. Okay, so the answer is we need 28 months. Okay, that's one. Number two is that how much is correct amount we have to pay in the 28th. It's not going to be 1576 because then you are paying too much. Okay? So how much is that? So check at the end of 27, we own 1391, right? So the next period you want to pay this amount because see, this is the amount you still owned plus interest payment. How do we do that? The loan amount last period times now the interest payment, which is based on the interest rate. F12 is our interest rate. So the interest payment, the principal repayment, and the balance, we do the same calculation. There's no change. So that's how we figure the last payment, which is the partial payment. So how do we know it's 28, right? So if the long term changed, maybe it's no longer 28, right? If long term changed to say, let's say 36, so we only need 24, right? So this is changing. So we cannot just say, hey, let's take a look now. Excel tells us if we look at the number, come on, it's going to be 28. But we're not going to use that to help Excel. We have to use something which is able to change when the long-term change automatically reflect this actual long period. Now think about that. We are doing that every month, 1576, right? So it's annuity with the same amount, right? We can go to the time value money, use a payment function. So we want to figure out now actual loan period. So what we're going to do is the period function in the time value money, NPER, right? So this asks, what is a monthly rate? How much we are paying every month, right? We are doing this regular plus extra, right, all the way. Then we borrowed 40,000. Okay, so this we use NPER, and we found out it takes about 27.89 months to pay off if we keep doing extra payment, right? But we do know in reality we don't have like partial 0.89 months. We have to use the whole month. So we have to round up to 28. Excel has a roundup option. You can use roundup. You just refer to the information, then you see how many decimal you want to keep. In this case, we want to keep a whole period without any decimal. Okay, so we have 28 months, right? 20 months. So this is the actual long period in change to 28 and no longer 48. Okay, so this will help us a lot to do the if function, make it flexible, right? Recall that we were using that use 48 as indicator to say, hey, are we in the first 48 or not? So we will do similarly for the actual payment. Okay, so what we do is so we have calculation. What we do is use if function, check the previous, say, hey, we in the first 28 months, so we lock 28 months. If it is in the first 28 months, so we still adding 1. Otherwise, we no longer display any informations. Okay, so that's only 28, right? Okay, that's good. We're going to show you that the functions, the formulas in the next slide, but let me focus on the calculation. So next, I'm going to do the 3-column CDE, which is interest payment, principal repayment, remaining balance. So they can work the same way, which is like this. Okay. So I'm sorry. Okay. So actually, I copied from the previous basic if function version because these actually work same thing, work same way. We don't need to change empty, otherwise do the calculation, which is same set calculation. So again, I'm going to also updating, right? I'm also updating till 28, right? You see, although we do have actual information after 28. Now the payment, recall the payment, we have 3 kind payment. We have 1576, that's 1, right? X2. We have partial in the last period, right? 1400. Then we have nothing, right? No longer display anything. So we have 3 possible payment. One is 1576, 1400, partial, or nothing. So if we use simple nested if functions, we want to use 2 layers. Okay. So what I'm going to do is I first check. Okay. If the current month indicates say, hey, is no longer display anything, I will do still not display anything. Then I will deal with partial payment for the last period, which is 28. Then I check if this period equal to the 28, right, which is our last actual loan period, the last one. So if the last one, what we're going to do is I'm going to remember how we do the partial payment. We were doing the last remaining balance times 1 plus rate, right? So then, because we are doing the formula for the month 1, we have to pretend use same kind of universal if functions. So if the month 1, the last remaining balance 40,000, right? We refer to the last one. Then time 1 plus the monthly rate. Like this. Okay. So this is if this period is last period. Although I'm doing this formula for the month 1, but we have to pretend, if this actually turned out to be the last one, how we do the calculation, right? So that is otherwise means it's not last period. It is also not beyond the last period, which means it's the first 27 period. So which is the regular plus X2. Right? So this close the inside layer. Then I also have the outside layer. Remember, each function, each layer, you have 3 piece informations. Conditional check, value action if it's true, value action if it's false. Okay. So let's see if it's working well. Okay, I'm double checking. You see, it is actually seems working well, right? It seems working well. So we can. The good thing is you can check by yourself to see if we are doing correct. I'm going to change 48 to 24. Okay. You see, actually the display actually automatically stopped, and actual loan period also changed to 18. Right. So it seems like we are working well. Okay, so this is the actual payment version. I only work you with one specific actual payment, which is all the way every month we do X2. Next, I'm going to ask you to do the balloon payment. Okay, so the balloon payment. It's supposed you have saved, if we saved 10,000, we want to see when is the time you may have the option to, you have enough money, we can pay off the remaining balance all at once. So we want to check when it's time the remaining balance is below 10,000, If we look at the actual number eyeball this version, it is 22. But we do know that if the long-term change, information change, this probably will change as well. So we cannot just say help Excel say, hey, let's find out that this is A46. No, because once information like changed to 24, right? If we change 24, so it's actually going to be 14, right? It's going to be A36, 38. So it's changing all the time. Okay, so I'm going to talk about 3 different ways. One is use VLOOKUP. The other is use if functions. Other is use index and match. Okay, so there's no limit how you solve this question. As long as you achieve the goal, which is the way you are solving the question is flexible. When the model change, the inputs change, your answer automatically updates. Okay, so I'm going to use VLOOKUP. Okay, one thing is, as you see, we don't really match exactly. So 10,000, we don't have 10,000 in the remaining balance. So we're going to use approximate match, right? The true option, right? But the true option, there's one issue is you have to sort in ascending order. Okay, so we have to sort by this remaining balance, but you see it does not work. Why? Because it is in descending order, right? We cannot VLOOKUP directly. Okay, so I'm going to do another way. Think about if the remaining balance is decreasing, which means the amount we pay off is increasing. So I'm going to say paid off. Okay. So I'm going to look at that. So what I'm going to do is use if this monthly indicator empty, otherwise I'm going to check how much we paid off. Remember, we own 40,000 to begin with. This is fixed, but I'm going to subtract the remaining balance. So that way I know how much we paid off how much we already paid off cumulatively. So I'm going to do that. Okay, so we have this remaining balance. I'm going to drag down all the way. Suppose we have 100 months also, right, at the end. Okay, so this is long paid off. I'm also going to use the month indicator. What I'm going to do is if this month is, if the month indicator is empty, otherwise I'm just going to copy the actual months, right? I'm just copy that, but I want to make it flexible, so that way when the information change, we also change. So what I'm doing is add a function to control display, right? So you see, so that way, so I have this already made up. So I'm going to use this as our VLOOKUP search table instead of the remaining balance, which is descending order. We cannot directly descending we cannot directly do that. Okay, so what I'm going to do is now use VLOOKUP. Okay, VLOOKUP. So we am going to say VLOOKUP. Right. So we have to search by this column F, the amount paid off. So that's 10,000. We are actually searching the difference between 40,000 and 10,000, right? So have we paid off 30,000 already? So that means we have enough money to pay 10,000 to pay off the remaining. So I'm going to search. Okay, then I'm going to drag down, so that way it works for all kind versions. Then I'm going to return the month indicator, which is second month, right? So you see it's 2021, right? 21. So 21, and the actual information that we actually are able to pay off the 22. So that makes sense because we are matching the one before, right? But one before, so we actually have to matching the one here. So it is okay. We only just need to do adjustment by adding one. So that's okay because this will automatically update it, always adding one. Okay, 22. So that's the use VLOOKUP. We kind of have to work around with the restriction in the VLOOKUP approximation searching. The second approach I'm going to use is use if functions. Okay, so what I'm going to check is if we already paid, if our remaining balance is below 10,000 or not. So I'm going to catch the first time we hit 10,000 or below. So I'm going to check if the balance is less than and equal to 10,000, right? This is our cutoff. Okay. If it's that, which means we actually reached 10,000 below goal. So I'm going to just indicate the month indicator. Okay. Otherwise, I'm not going to display anything. You can use 0 or not. Okay. I'm going to use a different color indicator. Okay. So as you see, if you look at this, right, when we arrive at 22 months, remaining balance is already below 10,000. So that way I'm going to display 22. If it's still above, I'm not going to display. Right, but we have so many. We only need to have 22. So then we want to use the first time we hit. So we use minimizing function, just report the one which is the smallest. Okay, in this case, okay, so I think I need to update the table all the way through. Okay, so the answer is 22, right? So this is another approach. We use if functions. Okay, so the last one actually is, I think we will like it a lot, index match combination. Okay, so I'm not going to create additional rules. So remember, match are able to match descending order as well if you use a -1 option. Do you still remember that? So what I'm going to do is I'm going to match the 10,000 here. Okay, so which will give us a row count. Then use row count, then use index function to find out the month indicator. Okay, so let me do the 2 steps if you forgot. Match the 10,000 here. I'm going to match through here the remaining balance. Okay, so I'm going to use -1 match. Okay, let me see. Okay, what I'm doing, I'm going to have, okay, it's 22, right? Okay, so then I'm going to use index function. Okay, because we know it is, so you have option to select whole table or only first column here. Okay, so I'm going to our row count. It is the information we have is 22, right? Okay, then I'm going to use column as first column. We only have 1 column. This is 21. Okay, so 21. Okay, so it's starting from this, it is 21. So as you see, we have 1 month off. Okay, 1 month off. That's okay. So same thing. What we're going to do is we're going to adjust by adding up 1. Okay, adjust by adding 1. Okay, so that is the third approach. Okay, so that's blown options. Blown options is the way when can we find out the months that you have remaining balance below 10,000. The reason I offer you different ways just to give you some ideas that you don't have to be limited to one way. So all these should be flexible. So change to 48 to 36, for example. So 24, right? 24 and the balloon payment 18, they all automatically change, means it's all flexible. That's the main goal here. Okay, so that's all that we talk about the loan amortization. Help you give you the idea that how to build a flexible model, use Excel, if function, and other tools. So you can check the answer key here, but I do encourage you to build start from scratch on these models. Okay, so that's all.